Welcome, students. During this lecture, we shall understand what is how to generate a pulsed laser. There are two techniques which are known as Q switching and mode locking. There is a difference between these two that we shall shortly see. Before that, we see what is a quality factor. However, about quality factor, we have studied earlier in our earlier lecture, but simple definition comes like this: Q quality factor is equals to peak frequency divided by the half intensity band frequency, full frequency width at half maximum. The quality factor Q of a laser is defined as omega naught, the peak frequency, uh, in angular frequency terms, into energy stored in particular mode divided by energy loss per second. So you see that smaller is the loss, higher is the Q value. That is, if I make it sharp, the Q increase must increase. Like this. So Q must increase. The intensity must increase. So this is defined as, because I am defining intensity over here. So intensity increases and we see intensity increases and this bandwidth decreases because loss becomes. Going further, in many applications of lasers, we require a pulsed source. Pulsed laser can be generated using a continuous laser, or another method is by making it emit pulses of light. So changing from a continuous laser to a pulse is not an efficient method because the the efficiency, the gain, and the cost is higher. So on the other hand, making it produce the making the laser to produce the and emit the pulses of light is a bit easier method, because that way we will have to make the devices, and that the devices may be more cumbersome to operate. So first you will generate a continuous laser and then convert it to a pulse laser. So costs become higher. Techniques of Q switching are techniques of producing a pulsed operation are Q switching and mode locking. Now, Q switching, it is used to produce high energy pulses, high power lasers. And as far as mode locking is concerned, it is used to produce ultra short pulses with a smaller energy. With mode locking, it is possible to produce lasers in the femtosecond region. That means much narrower uh, beams. Now, each method has its pros and cons, advantages and disadvantages, and applications as well. Q switching can be obtained using methods in which electro-optic modulators are used, or another way is to use a saturable absorber. Now, as far as mode locking is concerned, we see that there are two ways: active mode locking and passive mode locking. And this active one can be obtained, can be can be active mode locking is by using external signal, and passive mode locking is done by using a saturable absorber inside a laser cavity. Now let us have a look at mode Q switching. As you see in figure, there is a pump signal, and there is the amplifying medium, and we see two mirrors here, as always, mirror 1 and mirror 2. But what I see is a different thing, that is the shutter. One electro optic shutter may be there, and pumped signal is falling on it. It is the amplifying medium, gain medium, and a shutter is there. Now the shutter may open and close at our will, or may open or close automatically using some device. So that may be the difference. Now let us understand the mechanism behind it. When the shutter is closed, what happens? We send the pump signal to the amplifying medium, and the atoms are pumped to high level. And but when the shutter is closed, we get no feedback from mirror, because the beam does not build up, so there are losses. Now, because there are no stimulated emission, you know that stimulated emission is caused due to pump signal, but here we are not getting the feedback, and atoms are only lifting. The pump signal is only lifting the atoms. It is the only job. Now, important thing is that the the population inversion, it is increased to much higher level than in simple case, much higher level than the threshold inversion. When the population inversion is built to a required value, we suddenly open the shutter. Now the spontaneous emission reflects from mirror back and forth in amplifying medium, because spontaneous emission is essential. Along with population inversion, one thing is very important, that is the spontaneous emission, because if there is no spontaneous emission, we cannot have laser, because that regulates the speed and the lifetime of the population inversion species. So as we open the shutter, we get a huge pulse. So a special thing is that, main thing is that the gain given by active medium in one round trip is much greater than the loss. So the power increases, but the power does not always increase. There is an increase in power also, decrease in power also, and the overall power decreases. Since the growing beam consumes the population inversion, the latter decreases. So this is the main thing here, because for growing the beam from somewhere the power must come. So it decreases. When shutter is suddenly opened, a huge light pulse is generated. This technique is called Q switching. Now the quality factor, as discussed, low Q means high loss and high Q means low loss. When the shutter is kept closed and suddenly opened, Q factor is because the loss is low. That is the reason that its name is called Q switching. Here we see a graph on a single QT loss time graph. When the loss is high, the quality factor is low. When the loss is low, the quality factor is high. So it is plotted against time, shows the time variation of the cavity loss and quality factor on a single plot. Q is low when loss is high and the cavity is closed using a shutter. Q is high when loss is low and when the shutter is opened. For example, in a neodymium terbium aluminum garnet laser, the energy is 850 millijoules per pulse. The pulse width is 6 nanosecond and peak is at 140 megawatt, and the pulse repetition frequency is 10 hertz, and it emits 10 pulses per second. So this is the main thing here. In many applications, cutting, drilling, nuclear fusion experiments, we require pulsed laser. We can have a graph of output power with respect to T. A spike, an intense pulse is generated, and at time t is equals to 0, that is the reference time. So you please go through Ghatak and Tyagarajan. Osvaldo, and similar. So bye for now. We will be meeting again during next lecture. Thank you very much.